All right, for those just joining on YouTube, this is the Denver, Erlang, and Elixir meetup for Monday, October 2nd, 2023. The meetup tonight is sponsored by Praxis.io, which is a security company that is focused on Elixir and Phoenix. So the main product is a software security platform. Also available is Elixir developer security training, consulting. Really, if you're using Elixir in production at your company and have anything related to security, please come talk to us. The main event, big thank you to Zach for coming out tonight. His talk tonight is the story of a function. Zach is the creator of Ash Framework, which literally in the past week or so has seen a huge amount of publicity online.
This ought to be what we want. Oops,
I can see it, yeah.
Last. Okay, cool. And I thought I might see how this looks. Let me see, where does this, I can do this. Is this,
it's working, yeah.
Work? Okay,
nice. Looks good.
All right, we'll see. This is new Mac features, I guess. So cool. Hey everyone, I introduced myself, but for people watching on YouTube, my name is Zach Daniel. I'm the author of Ash Framework, which is a general purpose application development framework for Elixir. And that's the mouthful, but we'll explain a little bit more kind of what it is. But we're going to start a little bit with some regular Elixir, actually, to talk about some of the sort of problems that we're trying to solve. And there you go. So this chart actually looks, as was mentioned earlier, this chart actually looks a little bit different as of like a week or two ago, because we kind of blew up recently. A couple months ahead of schedule, actually. We have a lot of like DX stuff I was going to work on in like a month or two, but that's okay. We move quick, so no worries, we're taking care of it. But this chart now like spikes fully upward. But the idea here was just to show that like this is a project that's got a lot of traction and we've got people using it. They're in production. People care about it. It's not just sort of like a nothing burger. So let's talk about a function. This is, I think, going to be especially familiar to those familiar with, or especially resonant with those familiar with building like larger Phoenix applications. But this is a function. It's a baby function. It's beautiful. It's very simple. It's super easy to understand. If I go to a function like this and I'm like, nice, I got it. This is perfect. But this is a toddler function. It's still simple, but I would argue that it is heading towards a troubled childhood. Whoops. Yeah. And this is a toddler. Sorry. This is an adolescent function. So this is unpleasant. We don't really like to write our functions like this. But this function, I think, was more important, ignoring the fact that this is a big, long function that could be broken out into other functions. Can you guys see my mouse? Yes? No?
Yes. Yes.
Yes.
Yes. Okay, cool. Perfect. Thank you. So this function has opinions, right? So when we look at this, we see like sort is expected to be one of like top or latest, right? And we have this idea of like this thing called stats. And like, if you say yes, then you get some additional data back, right? Like these functions are like, you're building up this little language of like what it means to get your tweets. So that's what I mean when I say it talks back to its parents, which is that it sort of gets very opinionated. So this is a grown-up function. It's cleaned itself up. And I would argue that although it looks nice, I would argue that its potential has been wasted. So it's great. We've abstracted this stuff out. We've got filter tweets and sort tweets and add fields. So now that's like our stats function. And then we restrict access, right? And we see a lot of context functions in our Phoenix applications ultimately sort of become this sort of like builder pattern where we like support, filtering and pagination and sorting and all this sort of stuff. And they all ultimately end up looking kind of like similar, but, not exactly the same. So there's millions of these kinds of functions out there. Like this is the lifeblood of most Elixir applications. And I would say I would take this over a mutable object-oriented mess any day, right? Like this is not bad code. I don't look at this and think like, oh wow, this is just crap. I don't want to, but it is, I think that we can do better. And so that's kind of the impetus for for Ash Framework. So I'm going to show some other common problems that center around the idea of composition. And the idea here is that imperative code enforces artificial boundaries. And also, I'll say this class of problem exists in like all over the place. And once you see it, you can't unsee that this is like baking itself into your applications. So let's talk about a really simple one, which is order, right? Order matters when you write your code imperatively. So let's say we've got this like this little bit that's going to add some computed property, and we've got this add some computed field too. And this one has this implicit dependency on the value that was computed in this first one, right? And there are ways to build like computation systems, like if you wanted to add some calculated field, that will resolve their own dependencies. It's not a requirement of the way that we compute data that we have to do it in the right order. But our imperative code requires that this first one goes first and the second one goes second. And if somebody comes around and decides to switch these around or removes the first one, they say, oh, we don't need that field anymore. We don't want that in the API. So they just leave the second one, not realizing that it was derivative of the first one. And now you've got like some nil value that you didn't expect, or you get an error raised or whatever. It always it depends on what it looked like at the time. It depends on like how this calculation is written. But this is a really common problem. You see this kind of thing all over the place. So now we can talk about simple or optimized. So pick one, right, is the fundamental idea. And this is a common thing that we see all over the place is like, let's go back, is you have to make a choice up front. And this is something we do all the time, which is we all have it in our heads. We're cognizant of the fact that if we want to optimize it, it's going to get uglier. And so we just say, don't worry about it. Like, it's not a big deal. So in this example, we want to filter the tweets by two criteria, right? So in this case, we want to get the ones where the users are active. And then in this one, we want to get the ones where the user is a friend of the current user. But what you'll notice is this joins to the user table twice. And in real life, this doesn't matter. Like in real life, it's not a big deal if one function joins to users twice. But these kinds of things they stack, right? These are death by 1,000 cuts that stack up over time. So let's talk about how in regular Elixir code using Ecto, you would optimize these. This is what that would look like. And so you see here, we have this concept of joining friend links, and we check to see, is there a thing, already bound in our query called friend link? And if there is, then we're just going to return the query. And we do the same thing for users. There's this thing already bound in our query called users. And if there is, we'll return the query. Otherwise, we're going to join to users. And what's interesting about this is like, I don't have as much, like this is a lot more code. It's just more complicated to see what this does. And that is a problem, but I don't think it's the biggest problem. The biggest problem is what I would call an accidental embedded language. And accidental is an important part of that, right? Which is you have this thing now, this noun, friend link, that specifically refers to the friend links related to the user of the tweet. And you have this other thing down here called user that specifically refers to like the author of the tweet. These names can't be reused in this context. They have to keep their meaning. And this is a language, right? You have this concept of a tweet, and this friend link, like what if there's very reasonable to assume that a tweet could have multiple ways to be related to a friend link, like a friend link of the author or a friend link of the person who liked it or whatever it is, right? So we accidentally construct these languages that make it difficult to work on these things because somebody has to come in and they have to keep this language intact. I can't just remove join friend links or like change this because other places are going to be like using this name and it's reserved. So another issue, moving on to another one, we're going to revisit all these in a minute, but moving on to another issue is extensibility. And so I would say the right kind of composability will often imply extensibility. So this is like a classic thing that this is like generated a new context. This is a snippet from that. And let's say what you want to do is you want to see some analytics for or you want to like send off analytics where every time something happens with a user that shows up in like your analytics platform, like, I don't know, post hog or some whatever. And the only way to do that is to add code to all three of these. There is no other way to do it. You're not going to make your repo.insert function know about analytics. Like that's job is to insert into the database. You're not going to make your like user.changeSet function know about that. That's job is to like validate some data. And so the only way you do it is you add code everywhere. And then you go and make a new operation. You have to remember, you have to do the same thing. You have to bring that along. And there's ways you can get clever with it. You can make like a track analytics function that looks at the operation to just, you know what I mean? But ultimately you still have this code that is not extensible, that requires visiting every bit, like every function to make a change, to make like a cross-cutting change. So this is where Ash comes in. These are examples of some of the problems that we try to solve predominantly with declarative design. So the tagline model your domain, derive the rest essentially means you're going to use a declarative tool set to explain, like in a little DSL, which you'll see in a second, what your domain does, and then we'll derive a bunch of the pieces for you and we'll make them composable. And so here's a little bit of a resource overview. So this is not everything. The goal for after this is not for you to like know how to write a resource, but I want to show you the kinds of things that might appear in a resource so you can get a kind of a picture for it. So a resource might have attributes. Most of them will. Sometimes you have a resource that's backing like an external API and we'll hand wave that away, but then attributes don't matter as much. Or like backing like an event, I mean. But an attribute is like basic stuff. This is a quiz resource you can see at the top, and it's got a title and it's either published or pending, right? And then we've got, oh, that's weird that I had got it anyway. We've got relationships, and relationships are a way to relate one resource to another resource. So like this quiz has questions and it has quiz attempts and it has active attempts. So that's like every attempt that's not finished. And then we've got actions. Actions are kind of the lifeblood of Ash. And they're what I think separates it often from other frameworks that try to be like very CRUD oriented, whereas Ash has CRUD, but they're like templates. A CRUD action is like a type, a create action is a type of action. It's not the action itself. And so you can see we have this publish action here that's like semantic, that doesn't accept any changes. And it has this hook here called the change that will publish and does some additional work. And then it sets this attribute, the state attribute, to published. So you build out you actually declaratively model the verbs in your system in this way, not just the nouns. We have data layers. And so you can see we extended the resource to have the Ash Postgres data layer. And then we configured where it's stored and the repo that it uses. And we've got calculations, which we'll get into a little bit here shortly. But calculations let you compute, like lazily compute values based on a resource. Like, so in this case, this is like a calculation that is like the current user's latest score on this quiz. We've got code interfaces. So this is like your internal API. This defines your context functions, essentially. If you're familiar with Phoenix, you would have context functions. We do them a bit differently. You actually call the context function on the resource, but they ultimately go through an Ash API, which kind of acts like your context. And this will derive like interfaces that support all of the options and pagination and authorization and all these different things automatically. And so you don't have to like write a bunch of functions that end up looking the same and should be the same, because you want consistent interfaces to your application layer. We've got API layers. So this is all in the same resource, and we can configure, it's not very likely in real life that you will have one. I mean, it happens, but it's not the typical use case to have like one, also a JSON API and a GraphQL API, but it is possible. And what's important is that you can see that the way that you do that is you just map the concepts of that API layer back to your resource. So like, for instance, index is not a resource level thing. Index is like an HTTP sort of concept, right? Which is like list some instance in a resource. And so, or not HTTP, but a JSON API concept. And we just say, use the read action. And same thing for GraphQL. And we take care of the entire type generation, documentation generation. We take care of like the open API specifications, all these different things. So I'm going to talk a little bit about, that's this tour of the resource, but I'm going to talk a little bit more specific here. So given our actions, we can call them, like we can call our code interfaces with tweet.list, for example, and we can filter. So we can, every read action is filterable and sortable and paginatable, all that sort of stuff. We have calculations. So this is an example of a simple calculation, like it's a full name calculation. It's the first name with a space in the middle and the last name. And anybody who knows anything about like internationalization or anything like that knows that that's not how you do full names, but it's a good example that we use pretty much all the time. But what Ash will do is it will run that, it'll put that in the query. Like, so these will be filterable and sortable calculations, but it won't if it doesn't have to. So if I just load full name and I don't sort on it, this is actually not what it's going to do. It'll actually compute full name by running this in Elixir, right? So you can save round trips to the database. If I have a user with the first name and last name selected, and I say, give me the full name, Ash will just do it in Elixir. It won't even touch the database. And calculations can get very complicated. I mean, complicated is a bad word, but they can get as complex as they need to get to let you compute what you want to compute. So in this case, we have our example that we used before, where like this user is a friend of this other user, right? And this has this, we can use exists to find a related friend link, where the friend ID is the argument of user ID. So you can see an example usage down here, where we said sort by the count of likes, which is the count of related likes. Also, anybody who knows anything about building like a social media knows that you don't have a likes table that has one row per like, but or at least it gets more complicated than that is what I mean. But still, this is like a simple implementation. So we sort by the count of likes. We might filter where we can use this is friend of calculation and provide an argument. And then we run the query. And we can do all of these from every API layer. So this user ID will get translated to a query param in JSON API or into a input parameter in GraphQL. And so let's look at what we had before for composing our filter for active users and from friends of. And look at what that looks like in Ash. So we would add a calculation called user is active, which is to give me the first related user and the value of their active field. That's the value of user is active. And then we've got this is friend of. This is actually a little bit wrong now that I'm reading this out loud. This should be like exists user.friend links, but not a big deal. And these, you can see for active users and the join users. That's this whole calculation takes care of all of that. It will join to users under the hood for you. You don't have to do it. It knows that in order to figure out the active value of the related user, that it's going to have to join to do that. And we have the same thing here, where this is friend of will know that it's going to have to join the users and friend links table in order to compute that. And what that means is you can just use this like this. You can say ash.query.filter, pass in, well, there should be missing first argument of query, but say user is active and is friend of. And you can actually, you can do these in any order. So order doesn't matter anymore, which is, I think, an important part of this. You could compose it by first filtering this way and then later calling this one. So if you have, different cases where you might use each. But let's take a look at a different kind of composition, which is I've got this for active users and this from friends of, but what if I want things where they're for the active users or my friends? This kind of composition here won't work. You can't combine these two to get or of these two things. So this is your imperative code, again, enforcing an artificial boundary, which is for some reason, the definition of for active users and from friends of, like for a design reason, or not necessarily design reason, but a lacking design reason, I would say, is not composable in that way. You can't or them together. Now, here's one way you might do it. You might add into your little query builder over here, you might say or for friends of. And then you'll say, okay, join friend links, and then say or where. I'm curious if anybody can spot the bug or the problem with this implementation of or friends of. And while I take a drink of water, I'll let you guys poke at it and see if you see what the problem is. All right, no takers. All right. The problem is that this function joins to friend links every time. So what this actually is, if you tried to use, say, 4 active users and then pass it into or friends of, what you're actually going to get is more semantically better put as from friends of, or has at least one friend, right? Like, because you're going to do an inner join to the friend links, even though you're not actually, even though you're doing an or operation, you're saying or has a friend link where it's this user. And that's a problem. This join has to be switched to a left join. And so this is the kind of thing where it's like composing these gets really tricky for like no good reason. And in Ash, we will do that for you. So if you say is friend of here, and then you say or user is active, we will be able to tell that because this is on one side of an or, when we're joining under the hood, that we need a left join. We can't inner join because there's not a condition that always requires one of these to be present. And this is a really important kind of query optimization, not even necessarily optimization, but composability that you can't get if you try to build it by a bunch of chained functions over a query. It's a limiting way to build your query tools. Okay, let's move on and talk about extensibility. So we'll go back to our other example of trying to extend your operations to do some sort of analytics, right? So this is what it would look like in a context function. In Ash, we would have similar things. We would have actions. However, because these are declarative, we have tools that allow you to hook into every action on a resource. That's this changes block, which is kind of a vague word, but it's meant to be. A change is like a plug, but for an action. Or for a change set. So if you're familiar with plug, it takes a plug or takes a con, returns a con. This is a change. It takes a change set and returns a change set. And so what that means is we can add something external to the definition of our actions that will get every change set and have an opportunity to potentially modify it or potentially dispatch some sort of event or do whatever it is that you need to do. And this is actually analytics events, by the way, would be implemented with notifiers, but this is just a good example of how you can hook in custom behavior. Notifiers are another tool that you might use for that kind of thing. And of course, we don't throw away, like I've shown you a bunch of like things that you can call into specifically, but we don't throw away the ability to have good interfaces, right? So I can still make a feed action that takes a user and then uses my query tools to do this filtering so that the outside world doesn't have to know about is friend of if we don't want it to. It's up to us when we're building these things. But this feed action can be put up on any interface that we have. It can be rendered in a live view easily by calling a code interface function or just calling into the underlying like read action. It can be put into a GraphQL or a JSON API. And this is something we've seen pretty consistently is like the API layer becomes in a good way like an afterthought because you know that you can just drop in a one-liner to get the API built for whatever action you're doing. So you focus more on your domain, less on the API, and you can then just layer on APIs as you need them. And yeah, so this is an example of using code interface where I say, give me a function called feed that calls the feed action. If they're the same, you don't need to specify, but you can make them different. And you can specify positional arguments, and then you get tweet.feed defined for you. So we don't do any like Rails magic, dynamic dispatch stuff. Like this is a little bit of magic, and I understand that, but at the same time, it is explicit. Like the function exists and is defined. You explicitly ask for it. We don't do any magic function definitions. So I have another section after this, which is talking a little bit about kind of past, present, future It's not too long, but I wanted to stop and maybe ask if anybody has any questions about the stuff that we've talked about so far.
I actually just want to jump in and just clarify something you said early on when you were looking at kind of the two different interfaces. Effectively, if I understand correctly, you're saying you define these, you define again the domain stuff, and then it looks to me like, if I understand correctly, actually jumping or changing the interface for your application is pretty straightforward. If you're like going from like GraphQL to endpoints, right, to API, JSON API, like if I understand correctly, that's actually one of the things. One of the things I push really hard for is people to not, push logic into however they're resolving, or their controllers or their resolvers, right? And one of the reasons I preach that is like, hey, look, you never know when your actual interface to your application needs to change. I've been through that, right? And so if I understand correctly here, you're saying like, look, everything else stays the same, and this keeps that separation pretty clean. Am I understanding that correctly?
Yeah, absolutely. And I've seen very similar things where, especially when you start, like, it's really interesting because a lot of times we optimize for like day one stuff and we think like, well, we don't need this right now. But at the same time, it's like someday you're going to have a partner that wants an API and they don't want to use a GraphQL, or they want to use a JSON API, even though you've got GraphQL or whatever it is. You're going to have some reason to use some other thing. And yeah, absolutely. Ash is meant to be a rich application layer that you can put any interface on top of. So I've written custom interface. You can write custom Phoenix controllers too and call into your stuff. Like, you have the world's your oyster there. And these API extensions were written with tools that are accessible to anybody. So if you wanted to write like some custom gRPC thing, like we don't have gRPC yet, you can write a gRPC extension, and that gives you DSL tools. Like, you don't have to write this DSL. It gives you you give it a schema for a DSL, and it makes the DSL for you. So like, absolutely, it's designed to be that layer underneath your interfaces, your public interfaces.
I think the one other thing I'm trying to think through is that, and this is one of the things I experience that people encounter with GraphQL too, is that often things when we're dealing with like really strict framework definitions, we tend to find situations where like effectively the API kind of matches our database, right? And ultimately then logic happens, and this is part of the reason why like the MVC frameworks don't resonate well with me, despite the fact that I'm also not using models anymore, right? I don't think about it in that kind of terms, but is that it tends to be like the definitions really want to be kind of one-to-one. Like the resource on the outside is a match back to the to what we're looking at in the database, right? And again, like if it was that simple, we could literally just automate all of the code creation. There's always business logic that falls in. So we've seen really good, like kind of CRUD, I think, examples of that. And I guess I saw a little bit. I think what I'm struggling with right now is, somebody who's coming from like strongly bounded context, right? Like where I've got these things that will hit these tables, like, and I apologize. I'm probably just saw you showing an example because I saw you joining across tables. I guess, where's that code live? That's what I'm trying to figure out. Like, what files, like how's the application structure? And if that's too deep for right now, I'm more than happy to pause on that to let you go further with where you wanted to go, and then maybe circle back.
I think it's a great question.
Okay.
Why don't I show you what an example looks like? I'll use the one that we did in our training at ElixirConf, and I'll show you what a project looks like.
That'd be awesome. Thank you.
Switch to that. Let's see. Clicks. Okay. So this is, again, this is a slightly contrived example. Oh yeah, and I remember why Z is kind of annoying that in this one way, which is that if you zoom in, it doesn't make the sidebar bigger. So hopefully the sidebar is not like too abysmally small to see.
I think it's good enough for us to understand the file structure. Yeah, thank you.
So generally speaking, what your application looks like is you have contexts, or you have a context like accounts, and then you have an API module, and that contains some resources, and that resource, those resources will live over here. And oops, close this window that's popped up. Okay. And so you can see in here, we've got a bunch of like configuration things, but this defines like, user. And there's a lot in here because we have Ash authentication configured for users and all that sort of stuff. But if I go find a different one, like quiz, this is what we were kind of looking at before. So quiz, one of the things that I think is kind of important is like these concept of actions that don't have to map back to the data. So like this update action takes like an array of maps that will be mapped to questions. And then we're going to like, mutate those maps in some way. And then we're going to update our questions list. And you can do things in here. Like this, I think was really important to realize is like Ash is a bunch of stacked escape hatches with like default behaviors that you typically can use. So like I could say, for instance, do something crazy. And then I could say manual. And in this manual action, I can do anything I want. Basically, I get to take control, and the data layer isn't going to do what the data layer would have done.
I think you just showed me one of the things I needed to understand, which was, and in fact, that was going to be my follow-up question if you didn't hit it here, was cool. Your framework is neat. It doesn't, I can't imagine a world in which and this is not to hit on your framework, it's all frameworks where they already proactively know how to handle every situation. What you just showed us is like, cool, you need to write some custom stuff instead. Here's how you do it, right?
Yeah. And
that's really cool.
To illustrate like how this is all sort of stacked up with like lots of different things is we actually have a thing called generic actions. And generic actions actually, so you've noticed we have like types, like if we have like arguments, array map, these look kind of like ectotypes, but our types go a little bit further, quite a bit further. And so I could say an action like, this could be an action on a resource. Say hello. Oh, that's stupid autocomplete. And I can say, give me a name, allow no false. And then I can say run. And I could return, okay, hello, name, like this. So this is just an action that returns a string, takes a name and returns a string. And then I could go to my mutations and I can say, add a action called say hello that calls the say hello action. So like this bypasses anything about the resource actually. Like this is just a related action. It doesn't create anything. It doesn't update anything. And so you can use this to return statistics or to run a report or whatever thing you want.
Or whatever side effect you need. Yeah, that makes sense.
Exactly. And every Ash resource is an ecto schema. So I can also say like somewhere else from row and quicks.quiz and do like complex SQL queries that you can't think of how to do with Ash.
Yeah. And that thank you. I think that actually, without me pushing too hard, even like, I think you just hit on the thing, right? That under the hood, there's still ecto if really needed, and you can step away if you really need to. And I appreciate that. That's cool. All right. You may be converting me, man.
Any other questions? I'm happy to answer more questions, or I can move on to the next section.
Yep. On your previous slide, if you go back to your slideshow, it's so for the JSON API, you have it named as a string. Is there anything magical about strings in this situation, or do all strings just get converted into atoms?
Let me pull up that slide to remind myself what we're getting at here.
Yeah, so you have to type quiz, but then down below with the GraphQL, you have type quiz as an atom. Is there anything magical about a string in that situation, or just gets converted into an atom?
No, it's actually kind of an implementation detail of the actual extension, which is when we're building GraphQL, we use Absinthe under the hood, and Absinthe expects type names to be atoms. And we could do that magic. Like there's no real restriction. I'm looking at it now and it does kind of look a little weird. I'm pretty sure if I just said type quiz as an atom here, I'm actually like 99.9% sure that it would just work. Because yeah, I don't think it's a significant difference really between the two.
So like you could call any other type a string or an atom, but GraphQL expects an atom in that situation. So you couldn't submit a string there. Okay.
You know what? Honestly, I think you could. I think either would work either way. You would get a validation error, actually, now that I think about it. Yeah, I'd have to look at it. I don't. It's such an interesting thing because like I don't look at the little bits and bobs as often anymore. It's all like muscle memory to me. But yeah, I think you probably use atoms everywhere except for
Okay.
and
I was wondering if you were trying to prove a point in like the flexibility of it, or if you were trying to display this is like what you actually need to do. Like, yeah, what we're after with that slide.
I just copied it from a working resource.
Okay.
Okay. I'll move on. Well, this is kind of a trimmed down version of past, present, future from what I gave at ElixirConf. Basically, the feedback I got from my ElixirConf talk was more of the first half, less of the second. By the way, so that's what you guys got today. That's
so
what
Zach, sorry to
yes.
interrupt. Can I ask one more question? So
yeah,
like,
please do.
You know, if you're making macros, you can like view the output to see what it would do. So like, can you do the same with Ash, where you can say, give me like the derived code in this situation of like what the thing is that it would give me in this circumstance? Can you do that sort of thing?
Yes. The thing that's interesting is with Ash, it doesn't do nearly as much macro magic as people expect. So if we look here, like I've got this quiz resource, and I can say like ash.resource .info. Let's just say actions quiz. And this gives me back like just a big data structure with all of the actions. So like this is the publish action, it's got all these options, it's got these changes on it. And we use this sort of stuff everywhere. So really what Ash is like predominantly, there's some stuff that happens under the hood to like optimize some of this stuff, but predominantly what Ash is this big config that we get made, and then we hand that to some functions that react to that config. So when I say like, ash my API.create, and I pass in it, it's going to like go look up the action, and then it's going to follow the instructions, like so more like interpreted, I guess, than compiled in that regard, which has pros and cons. But in reality, it's like we aren't generating create functions under the hood that or anything like that. But yeah, it's not realistic actually, to answer your question, to exceed the expanded code of this, because it would be like thousands of lines of like, setting, validating every option and setting, like, it's just a lot. Maybe not thousands of lines, but it's a lot. Yeah.
So it's more productive to see the derived configuration, essentially.
Correct. Yeah. And we have like tons of like everything that you could want to know about a resource. It's all declared explicitly for this purpose, that you could then go look it up. And so like, I can see like, is this field sortable, and what are the authorizers, and like what notifiers are there? And like, not to suggest that you should use all these to like do, like you would be smart about it, but the point is that like, it's all there for a reason.
Okay.
Okay. Okay, past, present, future. So 1.0, for anybody who doesn't know, 1.0 was an accident, like a full-on mistake. So I have this tool called GetOps, which is super useful, and it saves me a lot of time. And what it does is basically it looks at your commit messages for a convention, what's called a conventional commit structure, and will determine if your next version should be like a point release or patch or a breaking change. And the convention is, if you make a breaking change, that you bump your major version. And I wasn't really paying attention one day, and I made a breaking change, but Ash was like pre 1.0, so it didn't really matter. It was like getting to 1.0, we were almost there, but I just committed. I just said, give me a new version, and I committed, and I pushed it up, and we had CI going for releases and everything. And I was like, so proud. I was like, cool, that'll go. And I woke up the next morning and I realized like, oh wait, Ash just went 1.0, like, and it updated the README and everything. That's how like all the tooling was so integrated. So I reached out to the folks at Hex, and I was like, hey, can I like undo this? And they were like, you're past the time limit, and they're pretty strict about the rules. So I was not allowed. I could revoke it, but then it was like, the 1.0 version would forever show as like revoked on Hex, and I would have to start at like 1.0.1, and I was like, you know what, we're just going to do it live. And so 1.0 came out. Yeah, so 2.0 was really like our big release, is the main thing. And we had a bunch of stuff, and I'm going to read some stuff out to you, but I do less explaining in this case. We have this concept called new types, which lets you essentially make subtypes of a thing. So you can say like an email is a new type of string that matches this regex, for example. We got open API support for automatically documenting your JSON APIs. We have an OBON integration that allows you to like to add what's called a trigger to your resource, where any entity, any like instance of a resource that matches a condition will get, you know, have a specific update action fired. So it's like a very easy way to like actually implement all different kinds of things. We have a tool for state machines, which essentially lets you turn a resource into a state machine. Complex calculation composition. I put this in here mostly because nobody knows how much that broke my brain. And nobody will ever know because it's behind the scenes. But the fact that you can have calculations that refer to calculations that refer to calculations, and like multiple things can refer to calculations with different inputs, and the solver will like realize it has to calculate that thing twice with different inputs and supply the values to different. It was crazy. It was really hard. It took me a long time. So I put that on this list. Anonymous aggregates. We saw some examples of those earlier, but basically calculations that say like, you know, the first related thing with this, or the count of related things that match this filter. Bulk operations. So we have bulk creates and bulk upserts, and I'm currently working on bulk updates and destroys. Atomics. Atomics are essentially like expression-based updates. So like incrementing score equals score plus 1. And you know, that's kind of table stakes if you're coming from Ecto, but ours works across data layers. So like you can do an atomic update on ETS or a CSV file, or the Postgres database, or we have a CubDB data layer that was just released a couple days ago. And so the idea is essentially like abstracting these concepts to work across data layers. And we've grown the core team. So we've got James Harton, Josh Price, and Barnabas Jovanovics, who are all now members of the core team in addition to myself, which many of our users are in production are pleased to know that the bus factor is getting bigger. And they've all been very instrumental in the success of Ash so far. And we've also been growing the ecosystem. So we've been building lots of packages. We have a tool called Spark, which is the underlying DSL tool. So you can use that to build DSLs, you know, in your own projects. Like you could implement all of Absinthe DSL using Spark. You could implement a Phoenix router using Spark. It has all the tools that you would need to build those kinds of DSLs. Ash authentication was huge. It's kind of our answer to mixed Phoenix Gen auth. We don't really like the code gen approach because we want to be able to update and add features and do all that, fix any security bugs, that sort of thing. Ash State Machine, which we talked about. Ash Oban. Reactor is what's the short term here? It is a graph-based Saga orchestrator that allows you to essentially write parallel sagas, and it will sort of solve them in order. It's a really cool tool, and we're going to be introducing it to Ash to handle a lot of the internal behaviors, and as well as exposing a plugin for adding Ash steps, like Ash specific steps to sagas, to give you shorthands for writing these like complex orchestrations around your resources. Ash double entry is another one. It's pretty new on the scene. We're still working on it, but essentially the idea is we're trying to build, bigger application tools, not just the little bits and bobs. And yeah, lots more on the way. We're rounding out features. So atomic updates, finished those recently. Atomic updates and upserts, that's mechanical, but we want to get that out before 2.0 is done. Fully atomic actions, maybe too much for me to explain. It's been a while. I've been talking for a while now, but fully atomic actions essentially allow us to take an action that has both validation and changes on it, check if those validations and changes can be done atomically in a single call to the database. And if they can, we will do it in a single call to the database to essentially protect you from a whole class of like transactional bugs that you might, like if you read a resource and say, you're not allowed to change from X to Y, that kind of thing. It's like, well, that works as long as you've locked the record. So there's all these different things that we're going to be able to solve with fully atomic actions. SQLite data layer is in the works. Got some stuff to work out, but we'll have that out hopefully in the next couple of weeks. MySQL is probably going to happen. I feel like SQLite is, people have asked me for SQLite. Nobody's actually asking for MySQL except for like one person. So I might take that off the list here. Yeah. And then Ash 3.0. So we're shifting focus to developer experience. And this is what I kind of had assumed the 3.0 release would be the one where we got a lot more traction, but everybody decided to jump the gun. And now we've got like hundreds of people. Anyway, that's a whole experience that I'll tell people about a different time. But we're going to be focusing a lot on developer experience. We're going to focus on generators right now. There are no new project generators or resource generators or anything like that. And we're also going to focus on best practice, like, guides for best practices, guides for better defaults, tooling, error handling, make things more debuggable, all that sort of stuff. But we're currently still in the last phase of heavy hitting features from 2.0. But we've actually had to front load a lot of this stuff because of so many people are coming on that need better guides. So you've probably seen, if you've been watching, you've seen a lot of guides come out and best practice type stuff. Okay, that is the overview. So anybody have any questions about that or any of the other stuff from before?